From Prairie Point, it's physical science time. What's up, guys? I hope you're doing well today. Take a moment, look at the focus essential question of how does force affect an object's motion, and our essential understanding of unbalanced forces affect an object's direction and acceleration. We're going to be leading up to that understanding throughout this whole unit. Our first way to understand our focus essential question is to know our first learning target, which is explain Newton's first law in terms of balanced and unbalanced forces. So today we're going to do a little bit something different. We're going to go to our science folder, the one that I have created for you. Click on Unit 2, and then click on Force Guided Notes. Once you're there, we're not going to make a copy. I repeat, we will not make a copy. We're just going to copy and paste the notes. So click Edit. Select all. It should become blue. Hit Command C. Go to an untitled document or create an untitled document. So you're going to go back to your science folder, hit Create, Document, Create and Share, hit Command V. Make sure that this document is in your science folder so that I can see what you have done. Also, you can now edit this and fill in the guided notes as we go today. So we'll stop this video and pause it so that you have the opportunity to do that. Do that now. Thanks. Success criteria, like usual. All right, I can define, I can identify, I can analyze, I can explain, but also with that success criteria tells you your level of understanding. This should clearly tell you where you are at in your understanding. Also, we have broken down the notes into your success criteria. So if you go through your notes and you can do this first part of these number notes and know those and tell me the definitions of force, inertia, and Newton's first law, and that's all you can do, that would be a very beginning level of understanding. And also, as you scroll down, you can see that I have done all the notes with that success criteria. So this should clearly and explicitly tell you where your level of understanding is. So take a moment, pause, and reflect about what that means for your own ownership of your own learning. It will really help you, and for my own learning, I wish I would have had that because I can clearly tell where it is that I'm at. If I can only define a force, I know that I'm beginning level. But if I can start identifying the forces acting on an object, I know that I will be at the approaching level, and so on and so forth. So let's get started. The first learning target that or the first success criteria we'll focus on is at the beginning level. I can define forces, inertia, and Newton's first law. Please follow along as I read the reading out loud and fill in your guided notes as we go. Remember, you can pause the video whenever you want. So first we need to define what forces are. I begin by reading, a force is a very important concept in physics and everyday life. In this chapter you will learn where forces come from, how they are measured, and how they are added and subtracted. So what is a force? A force is a push or pull. So I'm thinking to myself, push or pull, that's pretty easy. A force is actually the action that has the ability to change motion. So I'm thinking to myself, so forces affect the motion, which we learned in Unit 1. You need a force to start an object moving. You also need a force to change the object's motion if it is already moving. I also take a look and I see that force is defined over here, a push or pull, and the ability that involves the interaction or the ability to change the motion. So I would stop and pause and go back and fill my guided notes. The units of force, though, are a little bit different. Imagine mailing a package. How does that clerk know how much you should pay? They usually charge you in money per pound. A pound is a unit of force that is commonly used in the United States. Now remember, pound is a unit of force, so pound is weight, not mass. You measure weight in pounds on a scale. However, we use pounds in our everyday life. The scientists prefer newtons. Newtons is the scientific metric unit of force. A newton is defined as how much force can change an object's motion. We abbreviate Newton with that N there. And once again, it is defined nice and neat over here. If you missed any of this, we have the reading in your science folder. So take a moment, pause the video, and go back and fill in your guided. Our learning target next tells us that we need to be able to define inertia and Newton's first law, and our number notes also say that. So let's define inertia. The first law is often called the law of inertia. Whoops. Because inertia is the property of an object that resists change in motion. Inertia comes from mass. Objects with more mass have more inertia. To understand inertia, imagine moving a bowling ball and a golfing ball, which are at rest, figure 36. So being that good reader, I go down to figure 36 and I take a look. A bowling ball has 500 grams and a golf ball has 50 grams. So which one would be harder to move? We know that the bowling ball is 100 times more mass, so it has 100 times more inertia. Which needs more force to start moving? Well, think about it. How hard is it to move a bowling ball versus a golf ball? I infer that a bowling ball takes much more force to get moving at the same speed as the golf ball. Alright, well, so how does that lead up to Newton's first law? Well, Newton's first law says that objects continue in motion they already have unless acted on by a net force. I see that this font down here is in blue and it's bigger, so that must be important. That must be the definition of Newton's first law. When a net force is zero, objects at rest stay at rest, and objects in motion keep moving with the same speed and direction. And it is also defined up here. So Newton's first law states that an object in motion will remain in motion, and an object at rest will remain at rest unless acted upon by an outside unbalanced force. But what does it mean to be unbalanced? Well, an unbalanced force are when the forces are not, and the net force is not exactly zero. So it must be greater than 1. So I must infer what a balanced force is, and a balanced force must mean when the force or the net force equals exactly 0. So stop, pause, and go fill in your guided notes. Find what a force is, what inertia is, and Newton's first law. Remember, a force is a push or pull, inertia is the object's resistance to change in motion, and Newton's first law states that an object in motion will remain in motion unless acted upon by an outside force. Our next success criteria is I can identify forces acting on an object. This is the approaching level of understanding of Learning Target 2.1. So let's begin. What does this mean to identify forces acting on an object? Well, clearly, well, simply stated, you just have to be able to identify which forces are acting on an object and which way they're acting. So we're just going to do a couple examples here. The first one is a parachuter. Well, when I look at a parachute, I know that the force of gravity is acting downward, so I draw an arrow and put force of gravity. However, I know that air resistance also plays a role, so I draw an arrow upwards. And I say that you have air resistance. This is also friction because they are slowing down, resistance. Okay, now I go back to my book, so let's do another one real quick. We have our books here sitting on a table. Well, we have weight force, all right, of the books acting downwards because gravity always pulls downwards, so we have weight force. And I know from the Newton's first law that if the object is not moving, they must be balanced forces. So there must be a force acting on these books because they're not falling downwards. They're remaining motionless. So I'm going to call that force the normal force, and that's acting upwards. Take a moment, stop and pause, and do the swimmer and the football players. The football players now will have not just 2, like the swimmer, but will have 4 probably. Okay? Identify those forces. Alrighty, so hopefully you were able to identify those forces. Here's a couple of them. We have the propulsion force going that way, but we also have the water resistance going that way. She has a weight force, but she's not going down in the water, so there must be a force acting up on her as well, and we call that buoyant force. For this football player here, we see that his movement is going to the right, so that must be the tackle force, but his body is also applying a force in the opposite direction. He has a weight force, and he also has a force acting up on him or from the ground, which we call the normal force as well. So hopefully you're able to identify those. Our third success criteria, or the proficient success criteria, is I can analyze motion of an object in terms of balanced and unbalanced forces. So let's do an example here. A car is driving along the highway at a constant velocity. That is probably key there, constant velocity. Find the car's weight and the friction force if the engine produces a force of 2,000 newtons between the tires and the road, and the normal force, or the force that is perpendicular to the surface and applies the same force on the car, is 12,000 newtons. First thing that we have to do is identify our forces. So we see how that's identifying it helps us to learn how to analyze something. So you're asked to find the car's weight and friction force. You're given the normal force and the engine force. The normal force is 12,000 newtons. And the engine force is 2,000 newtons. And the car is moving at a constant velocity. Our relationships that we know is that Newton's first law states that if the car is moving at a constant velocity, the net force must be zero in the forward direction. So that tells me if the net force is zero in the forward direction, that the frictional force acting in the opposite direction must be 2,000 as well. And the car is not falling down through the ground, so that net force must be balanced as well. So the normal force, or the weight force, must be equal to the normal force. And now I can analyze that this car is moving at a constant velocity in the forward direction and not falling through the ground, because they are all balanced forces and the net force is zero. That is how we analyze the forces to explain motion. There's an example already filled out. Another example of analyzing the forces to explain motion. I think back to Happy Gilmore when he's yelling at the golf ball, trying to get the ball, thinking the ball is too good for its home and trying to get into its home. Now, why didn't the golf ball get all the way to its home? Yelling move will not make it move. You must apply a force. So, if you look at this bottom picture here, it shows you the force. I want you on your own or with a partner to analyze the forces of the ball that's not in motion and of the ball when it is in motion, and which force is bigger and why does that cause motion. So make sure to do this with a partner and do this in your guided notes. There is also, some more example problems, so do those as well. And finally, I want you to look at I can explain. There is a paragraph written out for you that is an example of an exceeding paragraph using Newton's first law. Take a look at that example, and then on your own you need to go to your kid blog and comment on someone else's post, but only comment using Learning Target 2.1. Explain Newton's first law in terms of unbalanced forces. So watch the video, analyze the video, and then comment explaining Newton's first law and how that applies to that video. Thanks and have a great day.